The James Webb Space Telescope has done what many thought impossible. It's found a galaxy so distant, so old, so wrong, that it might force us to rewrite everything we thought we knew about the early universe. But to understand why this changes everything, we have to rewind. Not to the Big Bang, but to 2022. Until then, Hubble held the record. GNZ11 was the farthest galaxy ever observed, a glowing ember from the infancy of the cosmos. But Hubble had limits. Its 2.4-meter mirror could only peer so far into deep time. Then came JWST, with a 6.5-meter eye tuned perfectly to infrared, ideal for catching the stretched, red-shifted whispers of the universe's oldest light. And it didn't just beat Hubble, it obliterated it. Early in its mission, Webb spotted a galaxy named GSZ 140, with a redshift of 14.32. That was big. Then came an even deeper one, MOM Z14. With a redshift of 14.44, it pushed our window into the past closer than ever to the dawn of creation. But the number wasn't what stopped scientists in their tracks. It was what this galaxy was. MOM Z14 is tiny, just 500 light-years across, a speck compared to our Milky Way's 100,000. But it burns with a furious brightness. A star-forming frenzy in the first few 100 million years of the universe? That shouldn't be possible. Even stranger, no supermassive black hole? Every major galaxy we know is anchored by one, a gravitational monster shaping everything around it. Yet here, in this infant cosmic nursery, there's nothing. Just newborn stars and silence. But that's not all. Spectroscopic data revealed something baffling. Nitrogen, a lot of it, and not just random traces. Signatures matching some of the oldest globular clusters orbiting the Milky Way. That means this galaxy isn't a pristine first-timer made of hydrogen and helium. No, it's been around the block. Stars have already formed, lived, and died, enriching the environment before MOM Z14 even got started. This changes the timeline. If galaxies were already forming stars in dense clusters this early, then the universe was assembling complexity far faster than we thought. Our models said early galaxies should be slow, dim, and chemically simple. MOM Z14 laughs in the face of that. And it's not alone. JWST is spotting more of these ancient, bright red dots scattered across the sky. Galaxies that shouldn't be there. Galaxies that defy our maps of cosmic history. Every one we find adds weight to a troubling question. Are our models wrong? Not necessarily wrong, but incomplete. They missed something. Something big. And just when you think it can't get stranger, it does. Some scientists, digging into the data, have proposed a radical idea. What if our entire universe exists inside a black hole? It sounds wild, but follow the logic. When a black hole forms, it creates an event horizon, an invisible boundary beyond which nothing escapes. Theoretically, everything that falls in becomes cut off from our universe. But what if, inside that boundary, a new universe begins? This is the idea behind black hole cosmology. It suggests that the Big Bang wasn't an explosion in empty space, but the result of matter collapsing into a black hole within a larger parent universe. The singularity? That was the seed. And the moment of collapse? The birth of time and space as we know it. Think about that. Every black hole could be a doorway to a baby universe, and ours might be one of them. That would also explain something else. The eerie fine-tuning of our universe. Why do the laws of physics seem so perfectly dialed for life? Maybe only black holes that produce stable, life-supporting universes are able to persist. Maybe we're the survivors of cosmic natural selection. And there's more. Researchers studying galaxy rotations have found an imbalance. Most galaxies spin in the same direction, but that's not supposed to happen. In a random universe, you'd expect an even split. This unexpected symmetry suggests a deeper, hidden structure, perhaps even a preferred axis across the cosmos. It challenges the long-held cosmological principle that the universe is the same in all directions. What if it isn't? And what if this is connected to how our universe began? A hint, perhaps, that the birth of our cosmos wasn't entirely random, but had a directional push, a signature from the parent black hole we emerged from. Some theories add another twist: torsion. In certain versions of Einstein's theory of gravity, space-time isn't just curved, it can twist. That twist could act as a repulsive force at extreme densities, preventing singularities from forming. Instead of collapsing to a point, the core of a black hole might bounce, expanding outward, birthing a new universe in the process. And maybe that's what we call the Big Bang. Suddenly, everything changes. The universe isn't a one-time event. It's part of a self-replicating cycle. Universes give rise to black holes, which spawn new universes. And on, endlessly. Even now, deep surveys of the cosmos are revealing ancient, massive galaxies just a few 100 million years after the Big Bang, far earlier than our models predict. These discoveries pile up. And they don't just challenge the timeline, they challenge the foundation. Of course, there's a chance we've simply measured something wrong, like the Milky Way's rotation speed. But what if we haven't? What if the universe is genuinely stranger than we've ever imagined? The more we look, the more that seems to be true. JWST has opened a window not just into the early universe, but into a deeper reality. One where galaxies like MOM Z14 aren't the exceptions, but the rule. One where the Big Bang wasn't the beginning, but a continuation. One where every answer leads to another, even stranger question. And that is where the real journey begins.